Okay, so we are moving into Unit 6, and this is our polar unit, so there's some characteristics that we need to talk about first regarding polar coordinates and conversion. So unlike a rectangular coordinate, polar coordinates are given in the form of r, theta. Okay, and there's a specific way that you need to look at this coordinate in order to plot it on the polar plane. So the first thing that you need to know is that you are going to look at theta first. Okay, so what theta is the angle of rotation from the 0-degree line on the x-axis. So what you need to remember is if the angle is positive, okay, meaning theta is greater than 0, then the rotation is counterclockwise. So very similar to what we've done before. Okay, it'll be counterclockwise. If the angle is negative, meaning theta is less than 0, okay, then the rotation will be clockwise. Okay. So once we look at that, we know where our angle is, or where theta is. Then we will look at the radius. And the radius, r, is the distance from the pole. Okay, so what is the pole? The pole on a polar coordinate plane would be equivalent to the origin on the rectangular coordinate plane. So it's basically 0, 0. If the value for r is positive, then you will move toward the angle. Okay, toward theta. If the value for r is negative, then you will move away from theta in the opposite direction. Okay, so these are some key characteristics that you need to remember. So this is our polar plane. And typically what we would call the y-axis is now called the theta is equal to pi over 2 line. I know, it's a mouthful. Our x-axis is called the polar axis. Okay, and that is the pole right there, dead center. Okay, so one thing that you need to keep in mind is that polar coordinates are not unique, and I'm about to show you this. Okay, because there are an infinite number of representations of r theta for one polar coordinate, because we have coterminal angles. So if you remember coterminal angles from the very beginning of the year, this is why we will have multiple representations. Okay, so we're going to plot just a couple of these, but you'll get the idea of what's happening. So remember here, this is r, this is theta. Okay, so we're going to look at theta first. Theta is pi over 4. So here we are at pi over 4. So we're sitting at the pole. Because my r value is 3, that means you go towards the angle, and see these concentric circles, you are going to go on the pi over 4 line 1, 2, 3 and plot this point. So that's this one right here in pink. Okay, that's how you would plot a polar coordinate. So let's take a look here at this. These are just the directions as to what we're doing. So we're going to go to 5 pi over 4, that's theta. Let's go to 5 pi over 4, it's right here. I'm sitting at the pole. Now, my r value is -3, which means I move away from the angle. So if I went this way, it's toward the angle. So this way is away. 1, 2, 3. It's in the same spot. So now I'm just going to put this around here that I'm plotting on top. Okay, so I'm hoping everybody's getting the idea that these are the same. Okay, so let's take a look at just a different, let me use one more. We'll go all the way down here to the bottom. This will be red. So -7 pi over 4. This is our angle. This is theta. So -7 pi over 4, we actually have to go in a clockwise rotation. So this is negative pi over 4. So that means -7 pi over 4 is actually on this line right here. My r value is 3. You're going to go towards the angle. So this is the same value as -7 pi over 4. So then I would plot, I'm just plotting basically around so they're all on top of each other. So that's how you would plot polar coordinates.